morning. I have marked your assignment and it shows great knowledge and great way of thinking. Thank you so much for your great effort. I have posted your marks on ETSB. Before I start, I get questions from David, from Jay, about and Olivia about the homework, and I'm going to do the questions. So I will do question 11, page 292. So I read the question. A small airplane is flying due north at 150 km per hour. When it encounters a wind of 80 km per hour from the east, what is the resultant ground velocity of the aeroplane? Okay, so when we have a question like this, we need to draw a picture. We have an aeroplane and it is going with a speed or with a velocity of 150 km per hour, and it was going north. So this is the vector that represents the aeroplane velocity. So this is 150 and this is velocity of the aeroplane. Okay, it says that it encounters a wind of 80 km from the east. So there is wind coming from the east here with an 80 km. You know, if you have something going in this way with a speed and another force make it shift a little bit with that. So we need to know after this shift, while this one is going this way and this one pushing that way, what will be the direction, the resultant, and what will be the velocity of the aeroplane, the resultant velocity of the aeroplane. So actually I need to add these two vectors. In order to add these two vectors, I have to make them head to tail. So this is the first velocity, this is the velocity of the aeroplane, and from the head I'm going to shift to put this here. So this is 80 km per hour, okay? And this angle is 90 degrees, okay? Now, what is the resultant? The resultant will be this vector. So we need to find two things. The first thing we need to find is what is the magnitude of the velocity and what is the direction. The direction will be this angle. Okay, so I need to find this resultant and this angle. If you look at this, this is a right triangle, so I can get the resultant using Pythagorean theorem. So resultant, the magnitude equal 80 squared plus 150 squared. This is the hypotenuse, and these are the two legs. So this is 6400. This is 22500. I guess 150 squared. So this will be 28900. So R, magnitude of the resultant, will be the square root of that. So resultant will be 170 kilometers per hour. Actually, we are not done. We just found the magnitude of the resultant vector. We need to find the direction because vectors must be magnitude and direction. So to get this angle, this is a right triangle, so I can use tan theta. I know the opposite and I know the adjacent, so 80 over 150, which is 8 over 15. So theta will equal 10 minus 1, 8 over 15. Oh, I forgot to tell you, you must put your calculator now in degree mode. When we do vectors, we need the calculator in degree mode, not radian. In calculus, we used radian. In vectors, we use degree. So I want to find 10 minus 1, 8 over 15, which is, this would be 28.07. So this angle is 28.7. So I can say that the resultant as a vector has a direction of 28 with the north, so north 28.07 towards the west, so W. Okay, and the magnitude of R is 170 kilometers per hour. Okay, this is how we do this type of questions. Okay, all right, so this is number 11. I'm going to do number 15. Question 15 says, we need to find we need to prove that 2 times Rm, so this is the midpoint, this is vector A, and this is vector A, because they have the same magnitude and the same direction, and this is the midpoint, so this is vector B and this is vector B. Okay, and we need to prove that 2 times Rm, vector Rm, equal Tp, this vector, plus vector Sq. Alright, so this is how I'm going to do this question. From this quadrilateral, from this shape, forget about this now, I want to find Rm as sum of some vectors. Rm will equal vector B plus vector Sq minus vector A, because I have to close here, so this is A, this is negative A. Okay, so from this shape, I want to start from the tail, so B, Sq minus A. Let's do Rm from the other quadrilateral, from here. start from here going to this, because this closes this shape. So the tail should be here, and the head, the tail of the first to the head of the last. So minus b plus vector t p plus vector a. Okay? Alright, again, what I did is I found vector Rm from this quadrilateral, RSQM. The tail here, so the resultant is connecting the tail of the first, so this is the tail of the first, has to be, and to the head of the last. So I go B, I go SQ, I go minus A. From this shape, I want the tail of the first to be here. So if this is B, this will be negative B, then TP, then A. Okay, now this is 1 and this is 2. If I add this 2, this will be 2 vector Rm. B minus B, I go and come back. So B minus B is 0. SQ plus TP, negative A plus A is 0. So this is the result. So I get Rm from this shape and from that quadrilateral, and then I added the two equations and I ended up with what they want me to prove. Okay? So this is question 15, page 292. I think I answered all your questions. I still have here can go 2 more minutes. So so the next lesson is scalar multiplication. What does this mean? It means when we multiply a vector by a number, what is the effect of that? So if I have vector A and I multiply it by 2, what we're going to have, this is vector 2A. Is vector parallel to A and double the size. So multiplying A by a scalar, which is 2, changed the size but didn't affect the direction. Okay, I will, alright, so what if I want to represent vector 1/2 A? So 1/2 A. What did it do? It changed the size, make it 1/2 of the original vector, and it continued in the same direction. What about if I want to find vector negative A? I multiply by -1. It will be parallel but in the opposite direction, same magnitude as vector A but opposite direction. So the negative will make the direction flips, go to the other direction. I will stop here and I'll continue in another video, okay?